Unit 3.5, the Isosceles triangle theorem. The Isosceles triangle theorem is a theorem that we're going to use a lot. We've already defined triangles. We said a scalene triangle is a triangle with no equal sides. An isosceles triangle is a triangle with at least two equal sides, which means an equilateral triangle is an isosceles triangle. And as we get to looking at the isosceles triangle theorem, we'll realize why I said before that an equilateral triangle is actually an isosceles triangle 3 times over. And here we go with that. In an isosceles triangle, it's a triangle with two equal sides. Those two sides that are equal are called the legs. We again represent equality with one little mark, and so the legs are those two equal sides, and the third side is called the base. The third side is called the base. The angles at the base, this angle right here and this angle right here, are called base angles. And the angle that is included between the two equal sides is called the vertex angle. Notice I put one mark in each of the base angles. We're going to learn here that the base angles of an isosceles triangle are equal. So let's name the legs. If we uh, gave this triangle some letters or some sides, then we could name it as we see down here, A, B, C. But what we want to do is define it, okay? And so the legs are the two equal sides. The base then would be the third side. The angle included between the two equal sides is called the vertex angle. It is the angle included between the legs of the isosceles triangle. And the base angles of an isosceles triangle then are the angles at the base. We might say the angles adjacent to the base, the ones next to the base, okay? So an isosceles triangle is a triangle with two equal sides. The two equal sides are called the legs. The third side is called the base. The angle included between the two equal sides, or the angle included between the legs, is called the vertex angle. And the angles at the base are called the base angles. Okay? Now, as we've marked here, if two sides of a triangle are equal, then the angles opposite are equal. The base angles of an isosceles triangle are equal. So angles opposite equal sides are equal, or vice versa, sides opposite equal angles are equal. So in a triangle, if two sides are equal, then the angles opposite those equal sides are equal, or vice versa. If two angles of a triangle are equal, then we can conclude that the sides opposite those equal angles are equal. Okay? Now, we might go ahead and talk about opposite. If we're going to talk about the angle opposite a certain side, we would draw that segment, and the angle opposite it would be the thing across from it. You see, across from that side would be this angle. If we wanted something adjacent, if we were talking about this side and we wanted angles adjacent to that, it would be the angles next to that. See, the ones that include that. So these two angles would be the angles adjacent to the blue leg there. And this angle over here would be the angle opposite that side. See that angle opposite in green versus the angles adjacent in red in relationship to the leg that I colored blue there. Okay? Okay, so let's go back to this theorem. In a triangle, sides opposite equal angles are equal, and angles opposite equal sides are equal. So we can say since AB and BC are equal, they're both 4, you see. Then the angles opposite those are equal, and the angle opposite side BC is angle 1. The angle opposite side AB is angle 2, so we can conclude that angle 1 is equal to angle 2. And if we were giving a reason and a proof, we would say angles opposite equal sides are equal. We're doing a little abbreviating there with our R. But anyway. And then in the next example, if this angle is 50 and this angle is 50, then the side across from that angle, BC, would be equal to the side across from that angle, which would be AB. So we could conclude that AB is equal to or congruent to BC with the reason sides opposite equal angles are equal. So if two sides of a triangle are equal, then angles opposite those equal sides are equal. Or if two sides of a or two angles of a triangle are equal, then the angles opposite those equal sides are equal. Now, this is not the isosceles triangle theorem. It's based on what's going on inside of an isosceles triangle. So for a reason there, we would not say isosceles triangle theorem. We would say angles opposite equal sides are equal, or we would say sides opposite equal angles are equal. The next thing we're going to look at is the actual isosceles triangle theorem. This number 3 here, theorem 315. The isosceles triangle theorem says that the bisector of the vertex angle of an isosceles triangle is perpendicular to the base at its midpoint. Now, I remember having a student, I would say, the bisector of the vertex angle of an isosceles triangle is perpendicular to the base at its midpoint. You may have heard the scarecrow on Wizard of Oz kind of throw some of that out. But anyway, the bisector of the vertex angle of an isosceles triangle is perpendicular to the base at its midpoint. And this student said, "You're talking too fast." So I said it slower. The bisector of the vertex angle of an isosceles triangle is perpendicular to the base at its midpoint. And she said, "You're still going too fast." And the reason I was going too fast, you see, I couldn't have gone slow enough, because she didn't know what all of those underlined words meant, because she hadn't been memorizing her geometry definitions as we went. So she didn't know what all those things meant, so her mind wasn't seeing what I was saying. It's just a bunch of words. Okay? So let's talk about it. We're talking about the bisector of an angle. Well, what a bisector of an angle does, it divides an angle into two equal angles. See, so our brain had to do that real fast because we know our vocabulary. Well, the bisector of what angle? Well, the vertex angle. The vertex angle of what? An isosceles triangle. Oh, that's a triangle with two equal sides. Those two equal sides are called the legs, and the angle that forms the legs is called the vertex angle. So we're talking about bisecting this angle, and an angle bisector is a ray, that thing, see, that divides an angle into two equal angles. Now, theoretically, the ray goes infinitely, so the angle goes infinitely, so that would be a ray. The bisector of the vertex angle of an isosceles triangle. We've got it drawn, an isosceles triangle and the vertex angle bisector. So there we are so far. What is this vertex angle bisector? It is what? Perpendicular. What are perpendicular? Perpendicular lines are two lines that intersect to form equal adjacent 90-degree angles. So that means that hits at 90. It hits what at 90? The base. The base is the third side. So the bisector of the vertex angle of an isosceles triangle is perpendicular to the base. Perpendicular to the base at what? Perpendicular to the base at its midpoint. What's midpoint? The base is midpoint. So this must be the midpoint of the base. Well, what's a midpoint? It's a point that divides a segment into two equal segments. You see what all we got? We've got four equalities, you see. We've got in green the fact that it's isosceles. We've got in red the fact that it's the bisector of the vertex angle. We got in black the fact that it's perpendicular, forms equal adjacent 90-degree angles. And we've got in blue the fact that it's a midpoint. Anytime, this is important, anytime that two are marked, two out of those four things are marked, you can automatically conclude that the other two are equal and justify it with the reason Isosceles triangle theorem. Example. Let's say that you had this picture and we had this. Well, that's two out of the four things. This is an isosceles triangle, and this comes from the vertex angle. It hits the midpoint. Because of that, we can automatically conclude that it's perpendicular and that this was the angle, vertex angle bisector, and we can justify those two statements with the reason Isosceles triangle theorem. We were given two of those things, and we automatically conclude that the other two are true based on the Isosceles triangle theorem. Okay? We can say, well, given this, let's be given that this is perpendicular and that these are equal. Well, that's two out of the four things. We've got that that's perpendicular and those are equal. So we can conclude now that it must be isosceles and that this must be a vertex angle bisector. And we can justify those two reasons with the isosceles triangle theorem. Okay? And we could do other combinations of two given and reach the conclusion that the other two are true. Okay? An isosceles triangle is a triangle with two equal sides. The two equal sides are called the legs. The third side is called the base. The angle included between the legs is called the vertex angle, and the angles at the base are called the base angles. If two sides of a triangle are equal, we know that the angles opposite those equal sides are equal. If two angles of a triangle are equal, then we know that the sides opposite those equal angles are equal. The isosceles triangle theorem says the bisector of the vertex angle of an isosceles triangle is perpendicular to the base at its midpoint. That creates for us four equalities. And we've said that anytime two out of those four equalities are true, we can go ahead and conclude that the other two are true based on the reason Isosceles triangle theorem. Any questions on that? Okay, so that gets us to the daily work, which we will begin to record in a moment.